Hello, everyone, and welcome to today's webinar brought to you by Lighthouse Technologies. Today's webinar is called Disrupting Delays, Overcoming the Three Perils of Software Development. My name is David Rippey. I'm Vice President of Marketing for Lighthouse Technologies. First, a few housekeeping issues. We are recording today's webinar. Everyone is on mute, and questions will be fielded after the presentation. However, if you have a question, please type it in the chat box with the presenter box on the left of the screen, and feel free to ask them whenever you like. If you have a technical problem, use chat to notify us so that we can assist you. And now a little bit about our presenter. Julie Hagan is Practice Manager for Lighthouse Technologies with over 20 years of software industry experience. She's served on a number of global multi-million-dollar large-scale software initiatives and ERP implementations. Julie is very skilled in business development and practice management, and she excels in tailoring processes to a metrics-driven, risk-based methodology. Also on the call is Jeff Van Fleet, our President and CEO of Lighthouse, and Brian Keck, who is our Software Testing Practice Manager. In case you missed our last webinar, here's a quick recap.
Welcome, everyone. Thank you for spending a bit of your time with us today. We appreciate it. As David mentioned, we had a webinar back at the end of June that discussed defects. So today we're going to be talking about delays, and those topics are very interrelated and have an impact on dollars. So we're going to start here today by doing a quick recap of that defects webinar, just in case you missed it. So we like to be really pragmatic here at Lighthouse so that you can take something away that is useful. So we focused our defects discussion on what causes them and how can we prevent them. So people are always asking us, where do defects come from? And the reality of it is that they come from us. We're people. We inject defects into every work product that we create, whether that be a sketch on a whiteboard or whether that be a design document or some code. We inject defects along the way. But what happens is we start looking for them a lot later than we should be, which causes a downstream negative effect in terms of cost and churn. So a lot of our clients also tell us that, well, we have commercial off-the-shelf systems, so I don't really need to worry about that. But just be cognizant of the fact that those are built by people too. So they have defects as well. They're likely to have fewer, but they will have them. And of course, as you extend those products with interfaces or custom functionality, they're at risk for defects as well. So the bottom line is, what can you do about it? Well, we like to boil things down into people, processes, and tools. So start with your people. Make sure that your developers, your testers are trained in what they should be doing. We have some assessments here that we use to help us determine if people are where they should be in terms of their knowledge so that they can get those gaps filled. Introduce inspections to your work products so that you can drive those defects out as early in the process as possible when they are the least expensive to remove and remediate. Make sure you've got appropriate test coverage via user story, requirements traceability, as well as both positive and negative testing. And make sure your exit criteria is robust and balanced and looking at not only the overall quality of the solution, but the effectiveness of your testing as well. So with all of that said, let's move on to delays.
And let me jump in for a second, Julie. So if you're listening in and you missed the defects webinar, but you'd like to hear more about that, just reach out to us. We'll have our contact information at the end, and or pay attention to the website because we'll be running the webinars again in the upcoming months. So,
thanks, Jeff. Okay, so some of you have seen a similar exercise before. We used one in our defects webinar, so some of these numbers will look similar, but not quite. So take just about 15, 20 seconds there, wherever you are, and think about what these numbers might mean in the context of software testing. So we're going to go with 5 seconds because in a webinar, 10, 15 is a really long time.
Come on, I wanted to play like the Alex Trebek's music.
So as some of you may have heard us say before, 5 is a multiplier. So what that means is that for every phase or work product where a defect slips, it becomes 5 times more expensive to remove and fix it for each phase or work product where it goes undetected. So that multiplier adds up really, really quickly. So a defect you could have driven out in a user story becomes exponentially more expensive if it slips all the way to production. 10,000 is the number of defects that we, Lighthouse, once found in a client's production system. So 10,000 is a really big number, so it was a really big development effort in system. The number I really want to focus on today is this 20,000 number. So believe it or not, when you think about all that goes into remediating 10,000 defects, it can take 20,000 man-weeks of effort. So that represents a 2-year delay, which is a little different than thinking, wow, that's a lot of defects. You really begin to quantify the delay that something like that can cause, because 2 years is obviously a long time. So if you've spent any time in this business at all, you will have seen these things happen, even if they haven't directly happened to you. So many of us have seen projects go completely off schedule, especially large change initiative, IT change initiative kind of projects. And we've also seen features cut to stay on schedule. So schedule-driven organizations are more likely to cut features. Organizations that are less schedule-driven are more likely to just overspend and be very late in their release.
And as you know, probably a lot of everybody knows, Standish Group publishes a lot of data out there that shows cost overruns and schedule overruns and feature underruns, if you will, on large enterprise initiatives. And I think the data shows when these systems are large systems, $1 million and greater systems, only 61% of the features actually make it into production in the time frame they expected to make it. So there's a lot of feature reduction that ends up happening.
Exactly, Jeff. So some development teams, they're okay weathering the storm. And based on how their leadership is handling the situation, will kind of determine whether they end up cutting features or overrunning. So similar to the defects discussion, we like to talk about why. Why do we think this happens? Well, again, here at Lighthouse, we always start with people. People will represent 65% of your improvement, typically speaking. So a well-trained staff will inject fewer defects, and that has an impact on your schedule, right? Because defects drive rework, which drives a schedule issue. Often we're inefficient as people, and sometimes we're not well-trained. Poor planning is a big issue in terms of schedule impact. So a couple things go into that, right? So anybody who's done project management knows the risk of scope creep, and you've always kind of got the business pushing. What else can we deliver? What else can we deliver? What else can we deliver? So unmanaged, that's going to drive an impact fairly quickly. Something that I say often, that we at Lighthouse say often, is that planning is hard. And planning is really hard when you don't have any concrete basis to build that plan, something objective. It's hard to recover from a bad plan, so we're going to talk a little bit about what we can do to make that more objective and a little bit more measurable, so that it's not just the last 2 weeks of any software development lifecycle. And then we have a lot of defect-related rework that is often not captured in anybody's plan. I mean, I would say rarely have we ever seen that captured. Yet we know it happens. We know that there are going to be bad fixes that break other things, and those things are going to have to be fixed. So we need to plan for them. So how do we do that? So we need to be predictive. So it starts with understanding the scope of what you're building and testing. So how do you know what that is? How do you know how big it is? Well, one way to do that is to use function points. So we often use the analogy of, think about it like building a house. So I've actually never built a house, but a lot of people have, and I hear all of their horror stories, so I might never do it. But if you know how many square feet the house is going to be, then it helps you understand how much work there's going to be in building it. So if you look at function points in building software in the same way that you look at square feet in building a house, then you can begin to measure how much work there is. So
and let me jump in for a second. So for those of you online that don't know what function points are, there's an international function point users group, IFPUG, that defines, let's just call a function point as a chunk of functionality in a software system. And IFPUG gives you tools and techniques from which you can measure how big the system is in terms of these function points. Then they give you translations from function points to code. So if you're building your system in C#, there's a translation of likely how much code there is in C# versus Java versus something else, just regular C or something. So there's a lot of good data out there that's being collected, and function points are language agnostic that you can use. So just for what it's worth, it might be worth looking up IFPUG.
Very good. So now that you know about how much work there is, now you need to think about how much time, historically on average, does it take my team to do that work so that we can plan appropriately. So if you track that kind of information, such as on the testing side, how long on average does it typically take my team to develop a manual test case, for example? Or how long does it typically take my team to execute a manual test case? Again, for example, if you have that data available to you, then you can begin to incorporate it in the planning process. What happens when you don't have a quantitative way to build that plan, and the plan's a little bit more gut feel, kind of based on what happened before, when you begin to go off the rails, important things tend to get cut, such as developers might start reducing their unit testing. So that means those defects that would have been removed are now going to slip, and now they're more expensive to find and remove. Or the testers, they start just doing positive testing. We call it happy path testing. Matching the system to requirements to see what it should be doing, but failing to execute the negative test, determining how the system responds if you treat it in a way it shouldn't be treated, and that's where all the defects are likely to be, generally 60% more. So when those activities get cut, it has a negative impact on the overall project. So now let's talk about measuring. So I talked about how important it is in the planning process to have certain pieces of data available to you, such as productivity data. If you're measuring all the way through, then you get some early identification, some forecasting, if you will, that the project may go off course. So you can't course correct if you don't know early enough that you're going off course in the first place.
That you had a course in the first place.
Yeah, that you even had a course, exactly. So to understand those trending potentials, some of the things that we like to look at are, one is defect remediation rates. So assuming you remembered to account for defect remediation time in your plan, you can now track against, okay, how are we doing compared to that plan? Did we think it was going to take on average 3 days to remediate a defect, but in reality it's taking 10 days to remediate a defect? It's going to send your plan off course pretty quickly. So on that same line of thinking, we're also measuring how many new defects are occurring for each failed test case. So what's the bad fix rate? How many things are being broken for every fix based on how many things we expected to be broken when we were doing our plan? We're looking at...
But let's talk about bad fix rate a little bit more. So, and Julie talks about this because most of our customers, we notice when we're talking with folks, when they're putting a plan together, they don't account for things like bad fix rate. So, and like she said, for every 100 things you fix, how many other things did you break? And did you allow for the time to find and fix those defects in your cycling? And even if you account for it, most people seem to only think the bad fix rate is about 10%. When you build the plan, but in reality, we've seen organizations at 25%, we've seen organizations at 40%. So for every 10 things you fix, you break 4 more things. That has a lot to do with how much pressure is on them to get the thing fixed really fast before they get beaten about the head and shoulders. So it's just paying attention to your history of your organization and what those numbers look like.
Exactly. And the same thing applies to the productivity of the test team. You know, we all go into testing engagements or testing cycles expecting that our team is going to perform at a certain rate. And a lot of things, both internal and external, have the ability to impact that. So it's really important to measure how are you really doing as compared to how you expected to be doing, so that you can find root causes of problems and drive them out, like Jess said, as early as possible, before it's just too late. Lastly, in measuring, I want to talk about test complete. How do you know when you're done? And this speaks a little bit to exit criteria that I talked about earlier on. So we do have to know, have we executed all of the test cases? How many of them passed? How many of them failed? How many critical, high, major, minor defects do we have? That's all really important information. But when you think about being finished with testing, it's about more than just those things. So if you have the ability to estimate how many defects are likely to be in the solution, then you can track actuals against that and kind of know, how am I doing? Is my testing good enough to find the defects, or are they still out there because my test cases aren't robust enough? You would have no idea, really, if you didn't have some way to pre-estimate how many defects are likely to be there. So it's something we like to take a look at. Another metric I want to talk about that's important here is a metric that we call mean time to defect or failure. So mean time to defect means across everybody who's testing, how often is any one tester finding a defect? So early in a testing cycle or early in a sprint, you expect it to be pretty often because the solution's pretty unstable at that point. But over time, that amount of time that it takes before anybody on the team is identifying one should get longer and longer and longer. So we like to see somewhere over 8, maybe even over 10 hours before anybody's finding a defect. And then as long as we are reasonably close to having found the number of defects that we predicted might be there, then you can start to feel pretty comfortable that we might be approaching a test complete kind of a state and we aren't leaving too many defects behind.
And let me add, one of the reasons that mean time to defect or mean time to failure is so important is because when you go to release to your user base or your customer base, if we had 10 testers or you had 10 testers working each for an hour and you found one bug, you got that 10 hours, right? You found one bug in 10 hours worth of effort. But if you release to 10,000 users all of a sudden and they're using your system each for an hour and you extrapolate that, they're going to find defects at that same rate and your help desk is going to get slammed. So just paying attention internally to your testing team and the rate of change that's going on from originally when you were first doing testing in the sprint, or maybe it's a hardening sprint, and you're running all your test cases. And early on, you're kind of fishing with dynamite, and you're finding bugs every 15 minutes. And later on, you see that slope of that line changing, and it's taking you 8 or 10 or even 12 hours to find a bug. That gives you some indication of the stability, and the stability is improving on the product. And your end users, when you go to production, are going to see the same kind of rate of change. There's still going to be bugs early on, and your help desk is going to get hit, but you want to pay attention to how much impact there's going to be there to that help desk.
It's a very good forecasting tool to be able to do that. So what can we do about it? And at the risk of sounding like a broken record, because we talk a lot about training, it is one of the most impactful things that you can do. So in order to know where the gaps are, do my developers and testers need more training, you kind of have to know where they are. And that's something that we're able to help with. We have put together some tools here internally for our benefit that help us know that. And we're able to then close those training gaps and allow our folks to be more effective. So, for example, on the development side, there's a commercially available tool called TechCheck. Improving that TechCheck score in a particular language can go a really long way towards improving the number of defects injected that a developer might be experiencing.
And removing,
and
right?
Removing.
Both
Yeah,
reducing the number you inject and increasing the number you remove. Yeah.
So think about all the things that we talked about in terms of the test plan, how much and how long. Again, planning is hard, and it's really hard to recover from a bad plan. And organizations struggle to take the time up front to build a concrete, quantifiable plan. It's best not to cut that time out and allow your teams to spend the time that it takes to have a reasonable, quantifiable plan that they can track against. And don't forget to estimate, include the rework in that plan. That's a really easy trap to fall into. As people, we tend to lay that plan out and tend to think for some reason that it's all going to go well. And the reality is there are going to be hiccups along the way, and we need to plan for that and have that in there. And then make sure you're tracking. I want to emphasize the word actionable metrics. So think about what you're tracking and what are you going to do about the information. I would never recommend that you just collect data for the sake of collecting data. If you're struggling with what to do with that data, there are a lot of resources out there that can help. So make sure that the data you're collecting is actionable. But if you do that, then the information has power. So you can begin to really understand what are the things happening that are likely to make my plan and my project go off course and cause a delay. Do I have more defects than I expected? Is it taking longer to remediate than I expected? Do I have more bad fixes than I expected? Is it taking me longer, or maybe it's taking me a shorter amount of time to write and execute test cases than I thought that it would? And then I'm just going to touch on automation quickly, both here and in a few minutes, because as we see our clients move, as we see the industry evolve from waterfall to agile development, automation is becoming very important because the manual test teams are getting backlogged, and it's hard for them to recover from that backlog without some automation. We do an entire webinar on that every few months or so where we really dig into it, but I wanted to mention it today as well.
Yeah, we also do executive roundtables in our different regions on that topic as well.
Yeah. So test complete is really important. So those things that Jeff and I talked about, those metrics around mean time to defect and defect estimation versus actual defect rates identified, it just helps you know when you're done. Too little testing, as you know, often causes rework and poor quality and can damage your brand. But you can actually over-test as well. You'll reach a point where the cost per defect is more than allowing those defects that are remaining to slip to production. So be cognizant of that as well.
The other point I wanted to mention just briefly on the metrics is it helps you with your management team explaining what's going on in terms of the quality of the work product and the effectiveness of your testing team. So if you've got some very clear measures that, as Julie said, are actionable, then you'll be able to explain what happened. The remediation time, you planned it for 2 weeks because historically the developers are taking 2 weeks to fix the bugs, and then something happened, the developers got sucked up into some other project, and now it's taken 3 weeks and it's blowing your testing schedule because of that. Those are the kind of things that helps you defend your position.
Right. It's a whole lot better to go to your leadership with that kind of objective data than to just go to them saying, well, development's messing up my plan.
Right.
It's just a lot more impactful to be able to have real numbers behind that statement. So I want to talk here for a minute about what happens as you do some of those things we talked about. As you get better at planning, as you start tracking actionable metrics, it increases your test process maturity. And as maturity increases, some interesting things start to happen in terms of predictability and schedule. So this orange line here, think of that as your plan line for all of your projects. And these blue dots are the actuals for all of your projects. So what tends to happen in reality is you may have 1 or 2 projects that the stars aligned and, unicorns, angels sang in the sky, and these projects came in below plan. But all these other projects tend to come in over in varying degrees, right? So what happens as your maturity gets better, your predictability improves. And as your predictability improves, because now you have historical data to tell you what's likely to happen, the projects start tightening up against this line. So this curve here, you're going to see get closer and closer to the line. And then your schedule begins to decrease as well. So it has a positive impact on both your predictability and your schedule.
Yeah, those metrics you're measuring can point to weaknesses in the organization that allow you to do training, but what it does is increases the efficiency of your organization, which is why you can now plan to get the work done faster than you could, 6 months ago or a year ago. So that's why that plan line starts dropping.
So Harvard Business Review tells us that 1 in 6 major software projects will overrun their schedule by 70%. That was impactful to us when we ran across that data point, because 70% is a lot. It's just a lot, and it further supports what we have found by talking to our clients in the marketplace, that so often these large projects are either overrunning schedule or under-delivering functionality, or both. So both defects and delays have an impact on dollars, and that's what we want to talk about next. So another fun data point here. So we talked about schedule overruns, but when you look at the cost impact of those types of overruns, the average is 200%. Not the outlier, but 1 in 6 will overrun by an average of 200%. So clearly, planning is hard, and there's some struggles out there.
And the average of all of them is 27%, right?
Exactly,
I mean,
right.
almost 30% overrun on average, and then 1 out of 6 averages, like, I thought it'd get it done in a year, and it took 3 years?
Yes,
Whew.
exactly.
Crazy.
It's a big statement. So I want to take our earlier example and translate it to dollars. So 5 is still the multiplier, right? Defects are still getting 5 times more expensive every time they slip from one work product to the next. 10,000 is the number of defects we're talking about here. So earlier you heard us say that to remediate all those defects can cause a schedule delay of 2 years. So 20,000 man weeks of effort, big project, so assuming 200 developers in that math. When you take that math a little bit further and assume, some cost around a typical developer, so I think we used $125,000 fully burdened rate for a developer, it's going to cost $50 million to remediate those defects. So when you begin to crunch the numbers, the Harvard Business Review, they're likely right on in terms of what these cost overruns look like. So we have a case study here that we just wanted to talk about and share with everybody today. So this particular client that we worked with was a property management company in the Cleveland area, and they were experiencing a period of rapid growth. So in order to accommodate some of that growth, they needed to transition their data center. So they moved from an on-site server to a larger kind of satellite-based rack system. So as most organizations would be, they were a little concerned about how that move might affect the interfacing of their systems. So they engaged with Lighthouse. We had the opportunity to go in and help them through that move. And what we found right away was that pretty quickly in the project, we had identified 10 times more defects than they were expecting. Because understand, they weren't changing functionality here. There was no new development at all. They were just moving their data center. So in doing that, right away, there were major problems with how these systems were going to interact with each other after the data center move. So it allowed us to reveal some really critical problems that would have brought their system, their business, completely to a halt had they turned those new servers on in their new data center and tried to execute their normal transaction process. So it was a big success for them. It reduced their defects as well as their delays, and a pretty big cost as well, because their estimate was that they saved over $165,000 by taking the time to put some risk mitigation around this data center move. So we just saw them a couple weeks ago. We did this about 2 years ago, and 2 weeks ago they were still talking about it.
Yeah.
So they were still really happy.
Right. It's small numbers here. I mean, depending on the size of your organization, right? For this organization, these are really big numbers. So it's all relative. So when you look at that 50 million number you talked about a few minutes ago, I mean, that's a big organization with 200 developers. This organization, much smaller organization, so the numbers are smaller, but the impact on their business is still tremendous.
Right, and the $165,000, that's really just around, what they would have had to spend otherwise to fix the problems. It doesn't account for the lost revenue of taking their business down.
Right.
Because they're just not even sure how to quantify that, so they didn't.
That's a good point.
So dollars are really important. So we know that defects and delays have an impact on them, but what else can we do? Are there other things we can do in our industry in the IT space to help us stay on budget? And it turns out there are. So I want to just hit on automation here again really quickly. So again, as teams move from waterfall to agile, we are seeing testing teams get backlogged. And in an effort to keep up, they're doing a couple of things. They are bringing historically offshore teams back onshore in an agile world, and they are introducing a greater amount of test automation from unit testing all the way up through the UI. So what they're gaining from that is more speed, broader test coverage, better accuracy. They're freeing up their SMEs. A lot of organizations, they don't have dedicated testers, so their subject matter experts, or SMEs, are out there doing the testing. They're more expensive than typical testers, and it pulls them away from their revenue-generating work, from helping the business enhance and grow, because they're just doing all this regression testing all the time. So again, we're not going to spend much time on it today because it's a big topic. But keep an eye out, for future webinars and roundtables on this subject.
Or just give us a call.
Yep, or give us a call.
We're glad to talk about it.
Yep, absolutely. So another way to stay on budget is to eliminate some hidden costs. So something that we are seeing a lot of from our clients that have engaged with offshore teams, typically through an outsourced relationship, is that their price point per hour was really low, which is why they entertained the idea and went down that path in the first place. But on the back end, they've seen a lot of decreased productivity driven by something we call churn. So churn is rework that stems from communication problems, cultural challenges, time zone, misalignment with offshore teams. So as that's occurring, it's taking some of our clients more management overhead as well as more time from their development team to manage all of that. So they're seeing costs that they didn't expect to have. So that's why we're calling them hidden costs. So an end result of that is that their quality is declining, their ROI is declining, and they're finding themselves in a frustrated situation and are looking for alternatives, to be just quite frank about it.
Which is why a lot of people are bringing it back onshore and moving to Agile, right?
Especially in our Agile world. Yep, exactly. Right. So CIO Magazine says that onshore outsourcers can mitigate those hidden costs we just talked about by as much as 65%. And I would say we are seeing that prove itself out in the marketplace. So just to put some quantification in terms of a visual around that concept. So the first three sections here, so we've got typical roles that you find in an outsourced test team situation here across the bottom, and up here across the top you've got some overall cost. So you can see that in just I'll call it rate for rate, hourly rate kind of comparison. Onshore companies such as Lighthouse, we are more expensive on an hourly rate, and you can see that with the orange bar there compared to the blue across a couple of these different roles. So testers for sure, test managers as well to a lesser degree, and on-site managers as well to a lesser degree than your pure play testers. But over here in project management is where you begin to see those hidden costs start to reveal themselves. It takes more project management on the client side to manage an offshore relationship versus an onshore relationship. So that's something that a lot of the companies we talk to are talking about quite often. In addition to that extra project management overhead, it can be as much as 25%. We've got the hidden costs that I talked about. So that is the churn that I mentioned around developers spending more time than they normally would, dealing with cultural impact, time zone misalignment, particularly in agile teams. The time zone issue is causing a struggle. As well as some of our clients are telling us that it takes more people offshore to complete the same amount of work as an onshore resource.
Well, to be fair, I think every client is saying that. It's just a degree of what they're saying, right?
Fair point, fair point. So some are saying, 2 to 1. We've heard as many as 7 to 1. So taking that into account in our bar chart here, we've added it all up to a total cost of ownership or a total blended rate. And when you do that, suddenly the onshore teams, start looking pretty good. So the message here is remember to consider your total cost when you're evaluating an offshore versus onshore relationship. So let's review.
Let's sum up.
We've talked about a lot of things. So piggybacking off of our webinar from June, the first peril in our 3 perils discussion here is defects. So remember to consider your people, your processes, your tools, and your metrics when thinking about reducing defects. So you're looking at, are your developers trained to the right level? Are your processes written down and adhered to consistently? Do you have any tools to help you do the right things faster? And notice I said do the right things faster. If you're already doing the wrong things, the tool is unlikely to help you. And measure all along the way so that you have that powerful information to make decisions all along the way. And you're shooting for a 95% defect removal efficiency. If you're doing those things, you ought to be able to get there.
And just a quick reminder for you guys out there, or folks out there, as we're starting to wrap up here, if you've got questions, make sure you chat them at us or chat them to us. Just chat them, and we'll make sure we address them here shortly.
So peril number 2 of our 3 perils, that's the delays. That's where we have focused the majority of our discussion today, but you will see a lot of the same themes because they're so interrelated when it comes to their impact on your large-scale projects or even small projects. Again, training, people first. 65% of your improvement comes from your people. Make sure they're trained appropriately, and that starts with getting an objective assessment of where they are so that you know what gaps you need to fill to get them to where you need them to be. Track actionable metrics, data that you can do something with, data that's going to give you a predictive indicator of whether or not your project's in trouble early, and data that's going to help you with your future planning so that you can become more predictable, just like that curve that we showed with all the blue dots against your plan line. That all goes into improving your test planning process. And lastly, increase your process maturity through training, inspecting requirements, driving defects out early, and measuring. The third peril is dollars. So like we said, defects and delays, they add up to dollars lost. So therefore, the methods that we talked about where you can pragmatically reduce those defects and delays are automatically going to start having an impact. Test as early as possible. Remember 5X. That defect that's on the whiteboard from where you were brainstorming is going to become 5 times more expensive by the time it makes its way into a user story. So have inspections, peer reviews, processes in place to drive those defects out at the work product level. Introduce automation whenever you can. Like Jeff mentioned, give us a call, if you're interested in that. We're happy to talk through it with you. And be mindful of the hidden cost of an offshore relationship. So all of that adds up to some key takeaways. So the first thing that I want everybody to remember is try not to feel overwhelmed. These software project failures, they are avoidable. And they're avoidable by introducing some of the things that we talked about today. Again, we like to be pragmatic. We want you to be able to take something away that you can use. So be mindful of that. Quantifiable planning. I can't say enough about it. Planning is hard, so put some pen to paper and some objectivity and measurement around building your plan so that you're not trying to recover from a bad plan.
Your test plan as well as your overall project plan.
Absolutely. Right. Measure all along the way. If you're not sure how, start small. Maybe start just by tracking how long does it take my team to develop and execute a test case. Those are some of the easiest things that you can begin to measure if people are just tracking their time, and start using that information in your future planning.
It's interesting, just a quick side note on that particular metric, it really helps you not only establish a baseline of how long it takes you to build a test case, but it helps your team define what is a test case so that everybody's consistently providing the same effective size of a test case. And today we see a lot of organizations that test case could be 10 steps or could be 400 steps, 400. Could be 400.
Impactful statement.
That's right. Yeah. But it causes your team to just get consistent, so that measure and so you can manage it works.
Test early. One of the easiest, most impactful things that you can do in that space is to introduce inspections if you're not already doing that. Inspect your user stories or your requirements and drive the defects out at that phase. We have an inspection class that we teach. Give us a call. We can talk through that with you. Maybe we can come and teach that class to your organization if you think that would be helpful. And lastly, consider an onshore alternative to your offshore relationship if you're experiencing the kind of churn that we talked about here today. It's really about being proactive, and it's easy to become reactive in an organization. Generally speaking, it's even easier to become reactive when you are responsible for a large-scale project and it begins going south. So do what you can to be proactive and have some control over your destiny, really. And it's going to have a positive impact on the cost.
Absolutely.
Okay, opening up for questions.
All right, so we had a few. The first is, will these approaches work with Agile?
Absolutely. So we get that question a lot because when we talk about defects slipping through the software development lifecycle, people automatically get that waterfall vision of a V model in their mind. But what's important to remember is that Agile is a series of work products as well. So even in a sprint environment, you can apply early defect detection. You can apply sprint planning, good planning principles, good measurement metrics tracking principles against your sprint, just as well as you could have against a traditional waterfall SDLC phase.
Okay, great. What do you think is the single most effective thing I can start doing today to minimize defects and therefore associated project delays?
So I know you said single, which ideally means one. And we always say people first, which causes me to want to zero in on the training like I normally do. But I have a hard time separating that from implementing inspections. Mm-hmm. So I am going to go with two. Those two things.
I'm sorry, that wasn't the question.
Okay, sorry. I'm making up my own rules here. I might not follow rules well. Training and artifact inspections, really, work product inspections are very quick wins that you can introduce to your team.
Okay. We had a question on metrics. Is there a particular tool you recommend for tracking metrics?
Good question. So we use Jira, and we selected Jira because we were able to build a custom dashboard on top of that platform fairly easily that we're able to use to track our metrics against. And Jira plugs in to a lot of ALM test management tools that are out there. So its ability to do those two things caused us to want to use Jira.
We have another question.
Yes.
Do you account what percentage of time for rework in a sprint?
That is a great question. So it depends on a couple of factors. One of those is the quantity and complexity of the stories being delivered in that sprint. So you can assess that by looking at story points. You also need to consider the maturity of the development team building the code. So a less mature development team will introduce more defects and remove fewer than a more mature development team, and that's directly related to how much rework might be there. Mm-hmm. A third factor to consider is it custom development versus a commercial off-the-shelf development. So looking at those three things will allow you to make determinations around, am I expecting 10% rework, 15%, all the way up to as much as 25% rework to account for in my plan.
Okay. I know you talked about this a little bit, a couple of times in this webinar, but can you elaborate on the hidden costs or the churn that you described with offshore vendors?
Yes, so the biggest thing we see are the increased project management effort that it takes because it's just harder managing an offshore team. Even as we see the industry has moved that way for a long time, so there are a lot of project managers out there that have experience doing it. They all still say that it takes a lot more of their time to do than managing an onshore team. So that's one factor.
Mm-hmm.
The second factor is time zone misalignment and cultural challenges drive miscommunication. And miscommunication almost always results in work that has to be refactored or redone based on the impact of those two things.
Yeah, in fact, I was having a conversation this morning with one of our employees talking about this topic, in that the cultural differences between onshore U.S.-based folks, if you will, and offshore allows for onshore people to ask questions. So if they see a problem or they think it's a problem, they're tending to ask a question way early than offshore teams. Offshore teams will tend, if you tell them to do something, I don't want to say stupid, but if you tell them to go build a test case against this particular user story, they will build that test case against the user story, whereas the onshore team will likely question the completeness or validity of that user story before building a test case that might be invalid.
Right.
So that's a big
That's a great example, and we see it all the time.
Yeah.
Okay.
That's a good question.
All right. Well, those are all the questions that we have. So I wanted, on behalf of everyone at Lighthouse, thank you for attending the Disrupting Delays webinar. Our team is standing by to answer your calls. The main number is 937-458-0055. Julie is at extension 328. Jeff is at extension 201, and Brian Keck is at extension 309. So that is 937-458-0055. You can talk to Julie, Jeff, or Brian at your convenience. So we hope you give us a call, and then we can answer more questions for you. Thank you very much for attending. Have a great day.